This tutorial will give you guidelines how to set up the remote PLC to send and receive signal values to and from Azure IoT Hub using MQTT protocol. With Azure Cloud, you can manipulate, collect, or visualize data received from remote devices. And Azure IoT Hub acts like a single place where one could create, register, monitor, and manage all the IoT devices connected on the cloud while also handling two-way communication between devices, sending and receiving telemetry data by the IoT devices. From ingesting and processing the local telemetry data through Azure Stream Analytics to storing and processing data at scale, Azure has a rich suite of data and analytics tightly integrated with the Azure IoT platform. Customers can ingest telemetry data from sensors that may be stored in Azure Cosmos DB or Azure Data Lake. From there, it can be leveraged to train machine learning models in Azure ML to perform predictive maintenance of devices or to deliver rich analytics through Power BI. Log into Microsoft Azure and go to the Azure portal. From the Azure homepage, select the plus Create a Resource option and then select IoT Hub. Next, click on Create. In the Basics tab, select a resource group or create a new one. To create a new one, select Create New and fill in the name you want to use. Enter a name for your hub. Select the region you want your hub to be located in. Select the location closest to you. For this tutorial, we will be using a free price tier, up to 8,000 messages per day. Select Networking to continue creating your hub. Select Management to continue creating your hub. Accept the default settings here. Select Review plus Create to review your choices. Select Create to start the deployment of your new hub. Your deployment will remain in progress for a few minutes while the hub is being created. Once the deployment is complete, select Go to Resource to open the new hub. Then go to Devices in the Device Management section. Click Add Device and give your PLC a name and click on Create. Microsoft Azure provides a tool, Azure IoT Explorer, which helps you manage devices by connecting to the IoT Hub that you have created. You can download the Azure IoT Explorer from the GitHub website. See the Azure IoT Explorer preview file available under the Release section. Install and start the Azure IoT Explorer on your PC. In the Resource panel of the IoT Hub you have just created, select Shared Access Policies. Click on IoT Owner and copy the primary connection string from the right-hand panel. In the Azure IoT Explorer, click on the plus Add Connection button and paste the primary connection string in the connection string text box. Next, click Save. The Azure IoT Hub provides two different mechanisms to authenticate devices and services: security tokens and X.509 certificates. In this example, we are going to use security tokens. We have prepared a test program with which we will demonstrate the transfer of data from the PLC to the IoT Hub and vice versa. First, let's set up the connection between remote PLC and the Azure IoT Hub. To do this, we need the Connect to MQTT server block. Go back to Azure IoT Explorer, where you can find the domain name of your IoT Hub in the host name field. Port should be specified as 8883. Also turn the SSL/TLS connection on. Client ID is the same as device ID. In the name field format, fill in the following: To generate SAS token, expand the connection string with SAS token section. In the symmetric key drop-down menu, select primary key. Enter a sufficiently high figure in expiration. Click on the Generate button and copy the part of the SAS token connection string form. After downloading the program into the remote PLC, click Online Monitor and check the status of the Connect to MQTT server block. 255 code means the connection is successful. In the Azure IoT Explorer, you should see your device connected to your IoT Hub. The main purpose of the program is to control circulation pump and to count daily working time of the pump. We use an asynchronous pulse generator block to control the pump. The pulse and pause widths are given via the AF4 and AF5 flags correspondingly. The values on these flags are formed through string-to-integer blocks, which convert string values to the corresponding numeric values. VB blocks have start values corresponding to the next characters. The string comparator block is used to activate the start flag F4, which activates the pulse generator. The string comparator block is activated if the character in the VB24 block is equal to 1. The start value of the VB24 block is equal to character 0. The weekly timer block is used to reset the pump runtime counting timer. The counting of the circulation pump operation time is performed by the stopwatch block. To send data to the IoT Hub, the Publish with MQTT block is used. The data is sent to the specified topic. In the settings of this block, we can create a template that can include both static symbols and dynamic information. In this case, we have generated a template in the JSON format. In order to receive data from the IoT Hub, we need the Subscribe with MQTT block. We will receive data from the specified topic. You also need to activate the Azure C2D feature. For simplicity, we will take a sequence of 5 characters. The first 4 will be responsible for the width of the pulse and pause, respectively, and the 5th one for turning the pump on/off. We will store data in blocks VB20, VB24. By running the online monitor, we can see that we have successfully connected to our IoT Hub and that the Publish with MQTT block is successfully publishing the data. Now let's see if the IoT Hub receives data accurately and in what format. Go to the Azure IoT Explorer, and in the Telemetry tab of your test PLC, you should see the messages being sent by your remote PLC in real time. As you can see, the data was received correctly in JSON format. Now let's send a message from the IoT Hub to the remote PLC. In the Azure IoT Explorer, click on the Cloud to Device Message tab of your test PLC. In the message body, enter the following: 10, 10, 1. Recall that for simplicity, We use a simplified format for sending commands to the controller. Click the Send Message to Device button and check the Subscribe with MQTT block. Status code 16 means that the block has successfully received the data and stored it in the appropriate VB blocks. Let's look at the updated data in the Telemetry tab. As you can see, organizing a two-way data transfer process between a remote PLC and the IoT Hub is quite simple. This concludes our tutorial.